So we've got a rational function because it's a reciprocal function.
I thought rational had...
I think I might have misled you, actually. The reciprocal function is where we have something like k over x only.
I thought rational was when you have an x on top.
Well, that's where I think I got it wrong.
Isn't rational gx over h?
So actually, we've got k over x plus something. Hang on, let me... I'm trying... I think what I told you was wrong. Rational... That's because you're chatting. Right, so let me maybe correct. We might have to correct something. I'm sorry about that. So rational is when we have... So reciprocal, we just have something over x. We might have a plus c after it. But rational is when we have a different sort of added to the x, so we change the denominator. And then we could also have, if we go up to the higher end one, so ax over... So we've got two different functions, top and bottom. So I think that's where I didn't read the textbook properly. So a reciprocal function where we've just got something over x, a rational function where the x has got something else done to it, another operation, and it can have an x on top and on bottom. Numerator and denominator. So if we look at this one, this is a rational function because it's got something added to the x as part of the denominator. So how do we find the domain? I mean, the same thing applies. How do we find the domain, range, and any asymptotes? So what are you making equal to 0?
Like, don't you make the x equals 0 and then the y equals 0 the second time?
Well, only if that's the value that can't happen. So what is it actually we're trying to remember? What is it that can't equal 0?
The denominator.
The denominator. So we know actually that what you're actually saying is this here, that cannot equal 0. Right? So because that's to do with x, our domain includes, well, our asymptote will be x plus 4 cannot equal to 0, therefore x cannot equal to what?
-4.
Negative 4. So what's the equation of the asymptote?
Negative.
X equals negative 4. So that's the equation of the asymptote. That there. Right, so that's the x one. So it's not that x is 0, it's the denominator is 0. And then what's the next thing that we say can't equal 0?
Y equals 0.
In this case, it's y is equal to 0, but what's the fact that we're using? That a what can't equal 0?
The whole equation.
But what is it that we've got? It's a
Function? I mean fraction?
fraction, good.
Sorry.
So we have a fraction, and a fraction cannot equal 0. So because y is equal to a fraction, alright, now it'd be different if there was a plus c. We probably need to have a look at those for a reciprocal. The fraction bit can't equal 0. So because y is only a fraction, we know that y cannot equal 0. Okay? So y cannot equal 0 because of the fraction. So what's the asymptote?
Y equals 0.
Y equals 0. That's the equation of the asymptote. Okay. Do you understand that? So the two things we've used, denominator can't equal 0, fraction can't equal 0. That's slightly different to x can't equal 0, y can't equal 0.
Wait, so there's two equations?
For asymptotes? Yeah. For these ones, yeah. For reciprocal and rational. So how would we state the domain and range then, if we've already worked out our asymptotes?
I think you missed a form for the rational one.
I missed a what?
There's 3 different forms in our text.
Yeah, I just put the beginning and the end.
Okay. Basically, can we do that with all functions?
Do what, so?
Make the denominator not equal to 0 and 1.
Well, if it's a fraction, so if it's a reciprocal or a rational, when the rational gets to this level, we have to talk about it. Alright, we need to talk about the difference. So, what's the domain and range again? So the domain are the x values and the range are the y values. So what do we say about the x values? So x could be any real number, but x
cannot equal -1.
Yeah. And the range is just as simple as y can equal any real number, but y cannot equal 0. I guess what we need to do, we probably need to go back to a reciprocal one and just discuss a couple of things there. Are you okay with that? Can I move down? Have you written it? So let's have a look at a reciprocal function. Let's say that y equals 3 over x plus 2. So it's not just a fraction bit, it's now got a plus 2 involved. So let's find domain and range, and of course any asymptotes, because we probably do that first. Right. So domain will be x, y. So what can we say? So this is where reciprocal is slightly easier than rational, because there's nothing happening to the x as part of the denominator. So what do we say then about our x value? Sorry, I've really struggled to hear you. But, so the denominator again, x is the denominator on its own, so that can't equal 0. So the domain, we could say x can be any real number, but x can't equal 0. Alright, make sense? What about the range then though? This is why it's important to think about it's a fraction, it's not just the y can't equal 0, because that's not always the case. So what is it that can't equal 0? So the fraction is not allowed to equal 0.
So what?
So therefore 3 over x. We've already dealt with the fact that x can't be 0. But another version is that 3 over x cannot equal 0, because the fraction can't equal 0. So what does that tell me about y? Because slightly different from before, y is not the fraction on its own. Y is the fraction plus 2. So actually, what can't y be? Not -2. Y can never be 0 plus 2. So 2. Do you understand that? Because the fraction bit still can't be 0. And the fraction can't be 0, y will never be 0 plus 2. Alright. So the range will be y can be any real number again, but y can't equal 2. So my asymptotes are x equals 0 and y equals 2. So can I move up, or are you still writing notes? So this is a rational. Why is it rational?
3x like something.
Yeah, because it's got something happening to the x. So we've got a rational function. Can I leave you then to find domain, range and asymptotes of this one? Give you a couple of minutes. Okay, going to talk me through it?
The bottom shape equals 0.
Yeah, so we've got 3x minus 6 is not allowed to equal 0. Therefore,
Therefore, x must be 2.
x cannot equal
Well,
2.
not equal
Yeah. So my domain is?
X in the any real number, x dot equal to.
Okay, so x equals 2 is an asymptote.
Y is the whole fraction.
So we know that y will never equal what? Well, this can't equal 0. Therefore, y can't equal
5.
0 plus 5. Therefore, y can't equal 5. So we say that y could be any real number, but y cannot equal 5. Right? So then y equals 5 is another asymptote. Simple enough? Should we go up a level then? Let's talk about, again, we have done this before. So we've got ones that look like this. So we've got y equals 2x plus 2 over 3x minus 1. So, what's different about this rational function?
There's an x on the top.
There's an x on the top as well. So what does this change? And what doesn't it change?
It makes a graph. And doesn't it make a type of graph?
Well, they all make a graph.
X is going to have more than one asymptote?
It could do, yeah, x might have, but normally we have more than one value of x when we have a what function in there. What function tends to lead to two possible values of x? So quadratic. So we haven't got a quadratic in our rational function, so that might lead to suggest maybe there isn't two x asymptotes yet. But if we had an x squared in there as well, that would add something to it. And it does go there, by the way. It does get to that point. But what I'm looking at is, what were the two rules we were looking at again? So our two rules were that the denominator can't equal 0. Is that still true?
Yes.
Yeah, that's the fundamental. We can't have that. So I can say that 3x minus 1 is not allowed to equal 0. Therefore, x is not allowed to equal a third. Alright?
And then do you plug that into x on the top?
Well, we could, but actually what we're saying is, by saying that, we don't actually care what the top is equal to. The bottom can't equal 0. Does that all make sense to everyone?
Mm-hmm.
So we could, we could put in to find out what the top value, what the numerator would be, but I don't care, because I'm not allowed to have it divide by 0. So we don't worry about it. Whatever's on the top does not affect what you are and aren't allowed to do with the denominator, because basically you're not allowed to divide by 0. It's undefined, isn't it? But what has changed? What was the other rule that we were using that to help us find the other one? So the second rule we had was a fraction cannot equal 0. Anyone study languages here? French, Spanish, whatever? Yeah? Do you ever get annoyed by the fact they're going, oh yeah, all ER verbs do this, this, this and this. Oh, except for this, this, this and this. Yeah? So here's your rule, but with these exceptions. Yeah? It's annoying,
Then why
isn't
do
it?
they have rules?
Exactly.
Doesn't even make sense.
But the rule is a fraction cannot equal 0 unless...
There's an X on the top and the bottom.
But why is that? There is only one fraction that can equal, well, an infinite number of fractions, but one situation. What's got to be true?
The top value are the same.
Not the same. The top can equal 0. So do you understand the difference between this one and, say, all the others we've looked at before? The numerator will always be 4. Therefore, that fraction can never equal 0. The numerator will always be 3. That fraction can never equal 0. This one, the numerator is always 1. That fraction can never equal 0. However, by putting a variable in the numerator, what can that numerator now equal?
0.
0. So this rule of fraction cannot equal 0 does not apply because unless the numerator can equal 0. And in this case, that can equal 0. That's fine. Now all we've done at the moment is shown that the fraction therefore can equal 0. So that's not our asymptote.
So then that's wrong. It's saying the bottom can equal 0?
No, that's still true.
But if the top equaled 0 and the bottom equaled... Never mind.
What, do you remember having that discussion, yeah?
I was going to say it's 1, but it's not.
Alright. So if the top equals 0, the fraction...
So then it's...
If the top equals 0, the denominator equals something else in this case, but the fraction will equal 0. That's not a problem. Yeah.
So the bottom can equal.
The bottom
How do you know that the
is
top
not...
and bottom can equal 0, or it's always the same?
Right, so the rule is the denominator can never equal 0. There's no rule simply because you can't divide by 0, yeah? However, the numerator can equal 0. Right? But if it is, 0 divided by anything is just 0. Okay?
Fraction does equal 0.
Yes, in this case it does. So this is what you've got to be aware of. When we have a rational function and you've got an x on the top, you've got a variable on the top, it is now possible for the fraction to equal 0. So that rule that we were using up here...
Always equal 0 then?
No, it won't always equal 0. Because if x is 1, 2, 3,
How
5...
would you know if x is 1, 2, 3?
Because how do you draw a graph? You choose lots of different values of x and find the y values, yeah? So what we're trying to do is figure out, is there an x value we're not allowed to use? And we found that. We found that x is not allowed to be a third, so we can't use that value. Now what we're trying to do is discover, is there any y value that will never occur, but we'll get closer and closer to it. Now we have talked about this before, a couple of times, hence the 0 divided by 0 discussion that we've had twice as well. But in this case, because the numerator changes depending on what x value I use, the numerator could be 0. So for instance, let's just show that. What value of x, what will x be for the numerator to be 0?
Minus
1.
Wait.
So we're saying that 2x plus 2 would have to equal 0. So x will equal
Minus 1.
minus 1. Okay? Now, what would the fraction be? So therefore, in this case, 2x plus 2 over 3x minus 1 would equal what?
0 over...
So it would equal 0 over
something. You don't know
3 times minus 1,
Minus,
Oh.
minus 4.
minus 4. But that is still 0. So what we're showing is, by doing that y now can equal 0. Right? So that whole fraction equaling 0 is not true, because if I were to go for x equals minus 1, I would get 0 over minus 4, which is 0. So there must be a different y value that will never happen. Do you remember how to find it? So it should be in your notes. And what do we know about asymptotes?
You just put that value into
This one, the third. Well, all I know, what if I do put a third into it? I have 2 times a third plus 2 over 3 times a third minus 1. And what do I get? Well, the whole point of this is because we get 2 and 2/3 on the top, but what do I get on the bottom? 0. So the whole point of that value is that that's not allowed to happen. Alright? So, okay. Yeah. Just wait for. So what we've got here, look, we've shown that if x is a third, the whole thing, therefore y, okay, will not happen. I can't do it. So x is not allowed to be a third. So let me just rewrite. X is not allowed to be a third. What we have also just shown is that normally what we say with a basic reciprocal or a basic rational function, a fraction can't equal 0. But because we've now got a variable on top, the numerator, now the fraction can equal 0. So we've still got a bit of work to do to find our y asymptote. Alright, are you with me at this stage? What we're trying to do? Yeah? So we've got the x. The x is still easy. It's still denominator 0, not allowed, blah, blah, blah. It's the y one that's a bit different. So how do we find it? So if I were to ask you to sketch a graph that has a y equals something asymptote, what would it look like? Which number? Okay. So if I wanted to have y equals 1 as an asymptote, I would draw a line where at y equals 1. At 1. What would my reciprocal function look like, or my rational function look like, if it had that as its asymptote? Let's say it had another asymptote of just x equals 0. Let's make it a nice easy reciprocal function. What would it look like?
this.
So it would look like this, and it would look like that, yeah?
How do you know which corners it goes through?
Yeah, how do you not know if it goes to red?
That's something we need to look into, because the basic reciprocal function looks like that, and then how do we get it to go in the other quadrants there? Well, yeah, we do the transformations of functions thing. We reflect, or we could reflect in the x or in the y-axis to get a different one. So do you remember your reflection stuff? So if this is f of x, how would I get this one?
F to the minus x.
So f of
Minus x.
minus x would be one version. Because what does f of minus x do? Yeah. So there's another way we could get the same thing, which would be minus f of x, because that would reflect in the... Okay, yeah. So if it would... This one reflects in the x-axis, this one reflects in the...
Y.
But because of the way it's... the thing, the graph, alright, it looks the same, yeah? Because of the...
0.
Mila looks like she wants to ask a question.
Why would that... Wait, I'm just trying to...
So if we reflect in the x-axis, this goes up here, and this one goes down there.
Yeah, it's just a little counterintuitive because the one that reflects in the y has a negative x in it,
Because if you make all x values negative, you actually reflect in the
Yes,
y-axis.
okay.
Okay, so back to what I wanted to talk about though. So if this is the red one, if this is the one we're talking about, all right, how could I find the asymptote for the y value that we get really, really close to? So when do I get really, really close to it, but not quite there? When what? Go on. I heard you say it, I think. Big number. So if we carry on up to infinity, right? What happens to this line?
Keeps getting closer.
I'm really bad at drawing that. Right? Same in the other direction. We get closer and closer as we get to infinity. So really what we want to do is, if we put a really big value of x in, we ought to get pretty close to the y asymptote, yeah? We still won't hit that value, but we can get really close to it. So using that, if we were to take this function, so 2x plus 2, 3x minus 1, so we've got 2x plus 2 over 3x minus 1. If we try an x value that's really big, 6,000. You're going to be easily pleased with a really big bank balance, aren't you? See, I was thinking like 1 million or something, but 6,000. I don't like the 6, just because that complicates it.
10,000.
Can we do a nice easy one, like, yeah, all right, 10,000? You'll understand why in a minute, because if I put...
Isn't it the difference between the top and the bottom?
Yeah, so do you remember I said if we put something like that in, this becomes 20,000 plus 2 over 30,000 minus 1.
Isn't it, and then isn't the y isotope 1?
No. So what value will we never actually get to? So if I were to choose an even bigger, let's say I did...
We're going to get to 1.
Oh wow.
We're going to be so close, but...
Sorry, that should be a 2.
We're going to get it.
As x gets bigger and bigger and bigger, do you remember I said that that plus 2 and that minus 1 are going to get less and less and less significant? Yeah? They're still massively significant because they stop something happening, but they get less significant in terms of what happens on the graph. So what will the plus 2 and minus 1 stop happening but not look like it's doing very much? It will stop it ever getting to exactly 2 over 3. Does that make sense?
Yeah.
So we will never get to anything 2 over 3 because of that plus 2 and minus 1. But you can see it because as we get x values really, really big, we get really close to 2 over 3. 2 billion over 3 billion. Well, if you do plus 2 and minus 1, it's very, very insignificant. But it does stop it ever being exactly 2 billion over 3 billion. 2 million billion over 3 million billion, but it will never be exactly that. There'll be a slight, tiny little difference. So that's what's happening here. So this difference here, for instance, might be the equivalent of 20 plus 2 over 30 minus 1, but all the way up here might be the equivalent of 20,000 over 30 plus 2 and minus 1. So the difference is tiny, but we still never get to it. Alright? So if we go back to our initial function, is there an easy way of seeing what it will be?
The number before the x.
The number before the x, yeah. Alright. So why don't you have a go at another one then? So
Wait, are we going to find the domain and range?
okay, well,
And asymptote with that one?
if you like.
I mean,
We've just found that, but the domain and range are therefore what? The domain is x can be any real number but x cannot be, what did we say?
A third.
A third. The range will be y can be any real number, but y will never be 2/3. The asymptotes, y equals 2/3 and x equals a third. Okay. So why don't you have a go at, well, I'm looking at exercise 5D on page 151. So we've done I'm just looking at question 1. We did B. Have a look at A, C, D, and then go on to question 2 and 3, and look at matching the graphs, using their asymptotes, that kind of thing.
5C, you said?
So 5D I'm looking at, exercise 5D. Or if you prefer, if you think it's more useful, go on to page 153 and do the review exercise that covers everything. So if you want a bit more practice on just this one, do exercise 5D. If you think, no, I'm going to have a review of everything, go on to the review exercises starting on page 153. Okay?
So like they would give us one of these